Hey, we're going to implement a grid movement system like this, where each time you move, the player snaps to the next position on the grid. There are going to be two variants. One, where each time you have to press a key to move one square, and the second, where you can hold it down and you'll keep moving. Let's get started. For this, I'm using the Unity 2D project template. First, we'll create a grid game board so we can see what's going on. I'll create a sprites folder and add in my 2x2 checkerboard image. This, along with this whole project, you'll be able to find on GitHub, which is linked in the description below if you need it. I'm going to change the mesh type to full rect so we can tile this. I'll just drag it into the hierarchy to create an object. Set the draw mode to tiled, and we'll do a 10 by 10 tiling. My image was 100 pixels wide, and by default, Unity does 100 pixels per unit, which means each square is 0.5 by 0.5. It'll just make things simpler if that's 1, so let's scale this up by 2. Okay, now let's create a new 2D sprite circle and call that player. We'll scale it down to 0.8 so it fits nicely in our squares. Our checkerboard isn't centered, so we'll just offset that by 0.5 in the X and Y direction so the origin is in the center of a square. Now create a scripts directory and a new C# script called GridMovement and drag that onto the player. Let's jump into the code. Our main focus here is the update method. Each frame we need to check if the user has pressed a movement button. There are two ways we can implement this. The user has to keep pressing the button or they can hold it down. We'll implement them both so you can choose which best suits your needs. So create a private bool isRepeatedMovement and we'll serialize this so you can toggle it on or off in the inspector to test out the difference. Then, if that is set, we use the input.getKey function which will trigger each frame it's held down. Else, we'll use the input.getKeyDown which only fires when you first press it down. So what is this input function I'm assigning this to? Well, C# provides you with a way of assigning a function to a variable, which means we can treat it in this way. We use the system.func call for this. We pass in keycode as that's the argument the function takes, and bool, which is the return value. Now we can use this input function in an if statement to see if we're pressing, say, the up arrow using keycode.upArrow. This will then call either GetKey or GetKeyDown depending on the value of isRepeatedMovement. When we do this, we're going to call a coroutine to do the movement as we want it to take some time and not snap immediately. I've called this move and we pass in the direction we're moving, in this case vector2.up. We can just fill out the rest of the branches for down, left and right. As the movement takes a bit of time to complete, we don't want to be able to call this again until it finishes. To do this, we wrap the whole of this logic in another if statement. We create a private boolean isMoving to track if we're moving, and then we only run the code if isMoving is false. The exclamation mark here negates the boolean, and this is the same as writing isMoving equals false. Great, we're nearly ready to create the coroutine, but before that I'll just add in two extra variables. We have a float move duration, which is how long it takes to perform the move, and a float that represents the grid size. In my example, the tiles are 1 by 1, but if you have some other scaling, this will enable us to cope with it. Both of these are serialized private variables, so we can play with them in the inspector. Okay, time for the coroutine. We have a private IEnumerator, that's the type that shows us it's a coroutine, called move, which takes in a vector2 direction. The very first thing we're going to do is set up that isMoving variable to true. This means that the update method isn't going to process any more inputs until we're done. So we should make sure at the end of the routine, when we're finished moving, we set isMoving back to false. Now for the movement, we're going to do a standard lerp loop. Don't worry if you haven't mastered these yet, I'll run you through it. First, we're going to make a note of our start and end states. In this case, that's a start position, which is where we are now. This script is attached to the player, so we can use the shortcut transform.position to access the position of the game object the script is attached to. Then we have end position, which is the start position plus the direction. Now the direction is a unit vector, so here we multiply that by the grid size variable we set up earlier, in case we want to handle different sized grids. Then the core of the loop focuses around an elapsed time, which we set at 0 to start with. We're going to loop with a while loop whilst our elapsed time is less than the move duration. Each time through the loop, we increase the elapsed time by time.delta time, which is the time elapsed since the last frame. Then we can calculate how far through the movement we are as a percent, as elapsed time divided by move duration. Then to calculate the current position, we lerp, that is to linearly interpolate between the start and end positions by this amount. We want the algorithm to loop straight away without delay, so we use yield return null to do that. That will proceed until we're done with moving. Afterwards, I always make sure we are exactly where we need to be by ensuring the position is set to the end position. That's all there is to it. Jumping back into Unity, we just need to make one last change. Both the player and the checkerboard are in the same layer, which means it doesn't know which to draw on top of the other. So we'll just set order in layer on the player to 1. We can hit play and see this in action. Currently, is repeated movement is not checked, so I have to press the key each time to move it. If you toggle the checkbox, then the movement carries on until you stop. Nice. To check our grid size works, we can scale up the checkerboard to a scale of, say, 6, so our boxes are 3 by 3. Now our circle isn't moving to this grid, so let's just centre our circle in the square, and then we can change the grid size to 3, which is how far across each square is. Now the circle jumps correctly between the squares. Hopefully this means that for whatever your project, this grid movement script will help you. And that's it, we're done. I hope you found this tutorial useful in some way. As ever, the code is available on GitHub and is linked in the description below. See you next time.